Good morning, Matrix. Today we'll be discussing scientific investigation skills. You always get them in your papers. You saw this since grade 10 in every test, every exam, every practical investigation you did. You always get these basic skills. The skills I'm referring to, I've indicated in red for you to see that you can know which skills we're talking about because they will be assessed once again. Look out for them in the two tests that you'll be writing this year. Your only assessments this year for grade 12 life sciences will be two tests, two formal tests, plus the two papers in September, plus the two papers at the end of the year. So you've got 6 assessments left in life sciences in your school career, and in each of them, the very same skills will be tested. So prepare yourself every time. Do not say, well, you've done this in grade 10, 11, you know these skills. Learners continue to lose marks where they're not supposed to lose marks. So every time, go through the skills again, practice them. It's not about studying knowledge. It's about scientific skills that we need in any science. So it doesn't matter what you will be doing next year. Wherever you go and study or whatever you do, you're going to need skills. And that's why it's so good in life sciences that we don't only test knowledge, you need basic skills. Things like basic calculations, interpreting data and graphs. And you will see how easy that is after our discussion today. But develop these skills, practice them, because they will be required of you in the exams. So I've compiled a number of years' exam papers here in this discussion. I will be using this document as a basis of discussion, and then I'll also attach it under resources. Look out for it on this website under resources, work through it, and you will see how valuable it will be in preparing yourself, because these skills bring you a lot of marks in the exams. If you, for instance, look at the paper we'll be discussing first, November 2016, you will see how many marks came from not knowledge, but from skills. As I mentioned, the ability to interpret graphs and a set of data, doing simple calculations, understanding the whole scientific process of how to design an experiment, how to write a hypothesis before you start, making your conclusions at the end, making sure that your investigation is reliable and valid. Those are the things that we will be discussing today. So let's look at some previous papers to see how the questions are asked. And you will see that the examiners, as I've said before, in life sciences, we appreciate the fact that they're always reasonable. So the most important piece of advice I can give you when it comes to graphs or data given as a set of stats is that you must say to the graph or the stats, talk to me. What story are you telling me? Look at this, because a graph is nothing but a picture, and a picture speaks 1,000 words. It tells you a story. What is this particular graph telling me? You ask yourself, whenever you get a graph or a set of stats, what are the trends here? What is the story here? In order to discern that, you need to read. So you say, the graph below shows the percentages of populations affected by food insecurity in some regions in the world. Now, food security, we know, refers to enough food all the time. So these people in these areas have had food insecurity. So let's go, first of all, to the x-axis. Always look at the x-axis. What are we talking about? We're talking about this region in the world. We're talking about that region. We're talking about South Asia, and we're talking about Central and South America. And here we see there's a key. So what are these bars about? Okay, I see this one that looks like this. The one is not shaded are the 1900s in comparison to what happened in the year 2000s. So this is a good example of a graph giving us information. All graphs give us information. If you're going to study any science, whether it's economic management sciences, social sciences, even languages, you need to interpret information. And the information is given in a picture. We call that picture a graph. So here you see what it's all about. Now, what's on the y-axis? It's the percentages of the people there affected by this food insecurity. So let's now look at the trends. We look at this part of the world, that's us, and we see that it's actually going a bit better, because in the 1900s, there was 35% food insecurity. That means 35% of the people were not sure where they'll get the next meal from. But coming towards the year 2000s, the last 20 years, the food insecurity, it says there it's all about food insecurity, is getting less. So things are going a bit better here. What about here? The insecurity in food is increased. What about here? No, it's going better. They're not so insecure anymore and there as well. I think now we've allowed this picture to speak to us. So that's what you always do when you get to a graph. Always tell yourself a graph is easy. It's a picture. And then you say to that picture, speak to me. Give me information. You take the information and now you're ready to answer the questions and see how reasonable these questions are. Which one of the above regions does not show improvement in its food security? So where are things going worse? We said here, things are going better because the insecurity is going down. Things are going better because insecurity is going down. It's going down. But here in East and North Africa, the food insecurity has increased from the 1900s to the 2000s. The picture tells me the answer. I don't need any knowledge to score 2 marks here. I can see it's East and North Africa. You too, you saw it. Its answer is number C. So what are the skills that you need when we talk about scientific investigations? You need to be able to identify the so-called variables in scientific study. When you do research, you've got variables. What are we talking about? The independent variable is nothing but the cause. What is causing the results? Now, that is a smart word we use for independent variable is simply something is causing something to happen. Like a cat is wagging its tail. What is the cause? The cat. What is the result? The tail is wagging. Can I turn it around? Can I say the tail is wagging the cat? No. It's the cat wagging its tail. So everything has a cause and everything has results. Results, or we can call it the effect. That's how life works. Everything has a cause and effect. Look at my example here. An investigation was conducted to determine the effect of the brightness of the light on your pupil size. So we all know what's going to happen. You can make a prediction. You go into a dark room, you have bright light, the pupil size is going to get smaller. So what is in this investigation? What is the cause? What is causing what? Is the bright light causing the pupil to become smaller? Yes. Or is it the pupil that's getting smaller is causing the light to shine brighter? No way. It's so easy to spot the cause and to see the results. So in this case, they always ask you in all assessments, look out for that in the tests and in the papers to come September and November. It's always a matter of the one is causing, the other one are the results. So an investigation was conducted to determine the effect of brightness of light. That is the independent variable. The cause is always the independent variable. So the brightness of the light, if they ask you in this study, will be the independent variable. And the diameter of the pupil, that means the size of the pupil, is the result of the brightness of the light. And what do we call the proper word for results? The diameter of the pupil will be the dependent variable. So what do we mean by controlled variables? So they will ask you in the exam, the variables, independent, dependent, but what are controlled variables? The controlled variables is the way we go about when we do a scientific study. It's everything we keep the same. Now, if you're going to do this investigation to see what is the effect of the brightness of light on the pupil size, what are you going to change? You're obviously going to bring a person into a dark room, and then you're going to put a light that's not so bright on, and then measure the pupil of the size of the eye. So, and then next time you bring the person in with brighter light, and then the third time brighter, and the fourth time very bright light. So you increase the brightness of the light and you check what's the effect on the eye. That's a scientific study that you can do. So what will you keep the same? Obviously, you're going to keep the person that you're using the same. You're going to keep the same room. You're going to measure where the light is shining. You're going to keep that distance from where the light is to the person's eye. You're going to keep that the same. You're just going to change the brightness of the bulbs. That's what you're going to change. What about temperature? You're going to keep the temperature the same. You're going to keep everything the same. The person should not have different drugs he's taking in between, painkillers and so on. It could affect the pupil size. You keep everything the same. You just change the thing that you're testing. So the control variables are all those things you keep the what? The same. So take note of that. Now they always ask you, write a hypothesis. So if we write a hypothesis, what are we doing? You need to be able to write a hypothesis. Hypothesis means that you must make a short prediction. So hypothesis is simply a short prediction that you make before the time. You're predicting the outcome of the experiment. That means you're not writing an explanation. I can make a prediction. The more time spent by grade 12 studying, the better the results will be. Now we can test that when we analyze the results and we check how much time you've spent and we check your results at the end of the year, we can test my hypothesis, was it true? So when you make a hypothesis, it is never a question. Hypothesis, I can write here for you, please never write it in the form of a question. The moment we see a question mark, we give you 0 for that hypothesis. Hypothesis is never a question. It's always just a short prediction, something like we saw now when we spoke about the brightness of the light on the diameter. Something like, the brighter the light, the smaller the diameter of the eye will be. And it also always includes cause and effect. The faster a boy runs, the shorter time you will spend in running to the shop. So it's all about cause and effect, how the one influences the other. That is hypothesis. If you write beyond one line in your exam book for hypothesis, you're probably going wrong. It should not be more than a one-liner, because now you're starting to explain you're going wrong. Just cause and effect, making your prediction. It's never a what? It's never a question. So what will be the investigative question when you look at this study that we're talking about here? The investigative question, like in this investigation, it was conducted to determine the effect of brightness of light on the diameter of the pupil of the eye. Can you quickly formulate now something different? It's not a hypothesis. Now the examiner asks you, formulate an investigative question. You can do that. Quickly get a question in your mind. Yes, something like, what is the effect of brightness of light on pupil size, question mark. That's investigative question. You score 2 marks for that. So hypothesis, we spoke about prediction. Sometimes they ask you to formulate a question that's something different from hypothesis. Conclusion, then they say, now, once the results are known, draw a conclusion. Now that's how we speak in English. You mustn't draw anything. Draw a conclusion means, what do I now realize? After looking at the results, I realize something. Now that is the conclusion I come to. So the planning is all about the planning steps that you will do. Let me just type it in here for you. Obviously, we know what the word planning means. Planning is everything you do before the experiment. Everything you plan. So you're going to plan. Now they're asking the exams. Here's a certain study that you've never seen, but write down the planning steps here. Then obviously, like in this case here that we've got with what will we plan? If you look at this investigation here that I've given the example here of the effect of brightness of light on the diameter of the pupil of the eye. Obviously, you're going to write, who will be my participants? Will I only use boys, girls? I must decide who's going to be my participants. So I decide on the participants. I decide on the place where it will be conducted. I decide on the equipment needed, the tools for measuring the pupil of the eye. I must get the tools ready, the gauges, the equipment. How will I record the data? Do I need permission of somebody? If I'm going to use, let's say, grade 8s at school, I must get permission from their parents. So all those you always write in your planning steps. But now, what are precautions? You also need to know for every investigation we need precautions. Now, precautions have to do not with safety necessarily. Please don't write safety measures. Precautions have to do with what can I do to make sure that I'm not messing up this whole experiment. Like for instance, I must use the same participants. I can't, with a certain brightness of light, use one guy, and with a brighter bulb, then I bring in another. I must be sure to use the same participants. I must be sure that there's no painkillers or drugs this person is using that may influence. That's a precaution. Before you use a certain participant, make sure he's not on painkillers, because the painkillers could impact. So precautions is everything that I must be sure of that will not impact negatively on my whole investigation, that somebody can say, no, but you've messed up this thing. It's invalid. It's not valid, your whole investigation. For instance, I must be sure that I have the distance right and keep the same distance every time where the bulb is towards the eye, because I'm measuring the brightness of the bulb. I'm changing from a 10 watt to a 60 watt to a 150 watt bulb, making it brighter and brighter. So I cannot then change the distance. So I must be sure of all those precautions. So these aspects of a scientific investigation you need to be sure of. Hypothesis, a short prediction. Investigative question ends with a question mark. Conclusion is, what do I realize at the end of the study? Now I can accept my hypothesis or reject it. I realized that what I predicted in the beginning was not right. But of course, before we start any investigation, one has the right to make a prediction. Maybe I say something like, the higher the temperature of the maximum temperature of a day, the greater the chances are for rain. Then I investigate that, and in the end I realize, no, it's not necessarily true. But I can make that prediction, that hypothesis, before the time. Then I investigate, and in the end I draw a conclusion that I need to reject my hypothesis. Planning is how you will do the experiment, and precautions is, what must I remember not to mess up? Now let's apply this knowledge here to the next one that we saw in 2016. And notice how many questions were asked in, for instance, one paper, November 2016, on skills. The skills count a lot of marks. You will be surprised. You must always prepare yourself well for the skills. Look here, there's more questions to come in that here. Questions, these refer to the investigation below. A scientist did an investigation on a healthy individual to determine the effect of drinking water on urine production. So you will always get investigations that you've never seen before, but that's okay. We must now just go and read and see what this is all about. So we're reading, this person wanted to see, is it so that if somebody drinks more water, perhaps, that he will produce more urine? Now, how did it do it? It says here, the participant was requested not to eat or drink for 4 hours before the investigation began. The investigation was conducted over a period of 3 days, and the following was done. On day 1, this person was given so much to drink. The next day, was given more to drink. Third day, given even more water to drink. For each day, then, what they did was the amount of urine produced by the participant was measured and then recorded over the next 4 hours after drinking that water. Day 1 that, day 2 that, day 3 that, and then an average was calculated. So now, which one, here comes the question. After describing all of that, so let's just look into a bit here. What do we see? What is the cause of more urine production? So can I say this, drinking the water, I can already, because we must always be quick to look out for cause and effect. Cause, what is the cause? And then the effect will be the results we're gathering. And the results, by the way, when we draw a graph, we always put on the y-axis. Let me just put this in brackets. The results you always put in the y-axis. The cause you always put, if you draw a graph, you always put it on the x-axis. Please remember that. So the results are always on the y-axis. Just want to erase this. This y is now written here. So you saw what I meant there. So the cause is the drinking of the water. So can I say the drinking of the water is the what variable? What can we type in? Remember what we said, the cause is always the independent variable. Independent variable. And if I draw a graph, it will come on the what axis? The x-axis. So the cause, the drinking water, is the independent variable. And the urine production will be the results. That's always the dependent variable. And if I draw a graph, it's going to be always plotted on the y-axis. So keeping this in mind, let's go answer the questions to see if they ask anything about this. So which one of the following correctly indicates the dependent variable and the independent variable? So remember we said the dependent variable are your what? What should I type in here? The dependent variable is always the results. And the independent variable is always the cause. So what was causing here? The more water this person was drinking, probably the more urine he was producing. That is my hypothesis. So now they list here in this question in 2016, the independent variable and the dependent variable. Let's see which of these sets of information are true here. The amount of urine produced was the cause. No, that's the results. So I'm not going to read further here. This is nonsense. A is not true. The amount of water that he was drinking caused the results of the amount of urine produced. That is my answer. I'm already spotting the answer. You too, you're spotting it there. Let's look at C and D. The amount of urine produced was the cause. No, that was the results. The people participating influenced the time. No. So it's easy. You see how reasonable the questions are. It's number B. Now, the list below contains some steps taken before and during the investigation. So before, permission was obtained to participate in the investigation. So let's just carefully look at this. Now, the list below contains some steps taken before and during the investigation. And then the question here says, which of the steps above can be considered as part of the planning? Now, planning is what you do when? Before conducting the investigation. So which of these 4 steps were planning steps? Permission was obtained. Obviously, we need permission before we start. That is one planning step. The measuring tool, yes, we need to decide which tool will we use before we continue in our planning. Now, did we do 3 and 4 before the time? Water was given to the participants? No, that was during the time. The amount of urine, that was during. So which of the steps can be seen as planning steps in this case? 1 and 2 we've marked there. Is there an option of 1 and 2 here? Yes, B, 1 and 2 only. So with no problem with that question. Now here's another study. Like I said, they always give us things we've never seen before, and that's okay, because we just read and we find out what's going on here. Let's read about this study. An investigation was carried out to determine the effect of caffeine on body temperature and pulse rate. So now I must already start picturing. Caffeine we find in like some cool drinks and also in coffee and energy drinks. All these energy drinks we have, they mostly contain caffeine. But this person wanted to see, if I drink that coffee, like here I've got my cup, if I drink the caffeine, how will it influence my body temperature? Like what they do in the mornings at school with you when they take your temperature. That caffeine that I'm drinking, that the chemical in the coffee, is it going to cause my temperature perhaps when they take my temperature at the gate with a thermometer that it's higher? Person is wondering about it. What about my pulse rate? If you take the pulse, is it perhaps going to be faster because of the caffeine? Now, what I like about this person, this investigator, he used 200, not just one person. Now that makes the results more reliable. When you use more participants or a great number like this, not just one person's pulse and his temperature, no, 200, giving them all caffeine. Now let's see how the person did it. the following procedure was followed. At the start of the investigation, each man's body temperature was measured, obviously, because you want to see how it increases. And the average of all the people then were calculated afterwards. Also, at the start of the investigation, each man's pulse rate was measured, and then the average of all the participants was calculated. So then, at the beginning now, they gave them each of this energy drink 100 milliliters containing the same amount of caffeine. The body temperature was then measured every 15 minutes for a period of 1 hour after drinking that drink. And then you calculate an average. Also, their pulse rate was then measured every 15 minutes because you're also interested in the pulse rate. All the participants were seated. Why were they seated? Because you don't want them to be running and so on, because that will influence their temperature and their pulse rate. You checking the effect of the caffeine. That's why this is a very clever precaution taken here. Let them all sit still. Otherwise, it will influence their pulse rate and the temperature. Now your investigation becomes invalid when you allow other things to influence your results and you're not testing those things. So the table below now gives us the stats taken here. So we want these stats to talk to us. So let's see how these stats can talk to us. Here's now, after giving the drink, at that point, 15 minutes, every 15 minutes, we took the temperature and we took the pulse rate. Very interesting. Can you spot the trend here? Now you say to these stats, talk to me. All right. So the temperature was that. Temperature increased. Suddenly it decreases again. So I've not done this study, but this is teaching me something. These stats here are telling, always look for trends. Always look for what's going up and down. So I'm seeing the caffeine looks like when drinking it, it increases your body temperature, yes, up to 30 minutes, and then it does not have an effect anymore. So the effect lasts for 30 minutes, because after that, I see the temperature is going down again. All right, let's look at the pulse rate. The person was at 76, which is quite normal in the beginning. Now, after drinking the caffeine, 15 minutes later, it went higher, and then even higher. But then once again, it looks like the caffeine definitely has an impact on up to 30 minutes, then it wears off, then the pulse rate comes down, just like the temperature comes down. So without looking at the questions, these stats have taught me a lot, and that's scientific skills, the ability to see trends. Are things getting worse? Are they getting higher, slower? What's happening? Now, describe the effect the caffeine had, this first question, on the body temperature and pulse rate after 15 minutes. So both of them increased. So as easy as that. How long after drinking the energy drink did the caffeine have its maximum effect? We said we could see it, that it was 30 minutes, and then after that, it did not really have an effect anymore. So here's a theory question. They combine with it. We're not going to discuss the theory of this now. State two factors that were kept constant. So that is how we work in science. We keep everything constant, and we just change the thing that we're testing. In this case, we were testing caffeine. So what was kept constant in this case? Let's go read here, because the answer will be here. They're asking us to read and to see what was kept constant. It was only men that were used, because women may have a different metabolism or different metabolic rate when it comes to how their metabolism functions. So one thing was kept constant. It was only men, and they were all seated. They were not allowed to do exercise. Those things were kept constant. And then the temperature was always taken constantly every 15 minutes. So it tells us here, you go get the answers there, you write it down, and you're scoring marks there. Now you need to be able to do simple calculations. You saw already they referred to, in this case, they referred to, you must calculate the average. Now, you know from even primary school how to calculate average. But if you maybe forgot what you were taught in primary school, or maybe what you've been taught in Mathlet, what is the average? You add up the total of everything, and you divide by the number of participants. You divide by the number of participants. So like here, let me use an example. Here is a certain study done by somebody. This person wanted to check out in a certain plant the growth rate of it in a certain plant every day. So he measured the stem, and he found at day 1, the stem grew, it grew, if it says here, growth in centimeters per day, the stem grew 0.5 centimeter in that day. The next day, day 2, the stem grew 1.2 centimeters. He measured it with a measuring tape in that day. On the third day, the stem grew 2.5 centimeters, and so he measured the growth in centimeters every day. Now, the question comes, calculate the average growth rate, the average, that word there. You can calculate the average of any sets of data, like the average mark of a test written for your class. Maybe you are 25 in your class of life sciences at the moment. What is the average mark for your class? 25 participants. You take each learner's mark, you add them up, add up the 25 and divide by the total number. If one learner was absent, 24 wrote, you divide by 24. So you add the total and you divide always by the number of participants. In this case, you add up that number, 0.5 plus 1.2 plus that, plus that, plus that, divided by what? Divided by 5. So that will be the average growth rate for this plant. So you can calculate the average of anything. Whenever they give you stats, you can calculate the average. So that is what is the whole situation with regards to average. But what about difference? Difference, they like to ask in the exams, what is the difference between this and that? Then you simply do what? You minus. Difference, you know, means minus. You simply subtract the two things from one another. If they ask you to calculate percentage, what does percentage mean? Percentage simply means, if I just write it here, percentage means a number out of the total. Percentage refers to a number out of the total amount. And that's always expressed as a number out of 100. So how do we calculate percentage then? Let's say the question is asked, indicate from here, what is the percentage growth this plant had after 1 day in comparison to the whole 5 days? What percentage of its growth did this plant grow in the first day? So then you say, right, the number is 0.5. So let's do that. So you say, now I want to calculate the percentage. So you're going to say 0.5. We always multiply by 100 because that's what percentage is all about. And then you say to yourself, so it's that 0.5 I must express now as a percentage divided by the total. So I must add up the total here because that is what percentage is all about. It's all about the number out of the total. So whatever total it is, like if I ask you, what did you score for the test out of 50? What percentage did you score? Percentage. Then you take your number, divide by the total of the test. It was 50, multiply by 100. In this case, the question was asked, what percentage growth of the total growth did the plant grow already on the first day? So that number is 0.5 out of the total. So you must go get the total here, write the total by adding up all these numbers, and then always multiply by 100, then you get the percentage. Now, a question that they love to ask in life sciences, and I find most learners get it wrong, is when they calculate percentage increase or decrease. And you do both in the same way. Let's look at increase. Doesn't matter if it's increase or decrease, but it's all about, you must have the starting point. Let's say they ask you, by what percentage did the plant increase in growth from day 2 to day 3, what is the percentage increase? The percentage increase in growth from this day to this day. By what percentage did it increase? Now that is a very simple calculation. Let's go and do that. So whenever you come across percentage increase, you do it according to this way, or this formula we can say. Increase or decrease, you do it like this. You say it's always a number out of the starting point. So you need to get the starting point. The starting point where you start off will be at the bottom. That's always what you put at the bottom. And what do you put at the top? You always put the difference, or the increase or the decrease. So at the top you put the increase. Divide by the starting point, and you always multiply by, because it's now a percentage. But the moment you see percentage, you do your division there and you multiply by 100, and that will be your answer. So what is the percentage increase, like in this example here, between the, how did the plant increase in size from day 2 to day 3? Then you say, well, the increase is now the difference. It increased with 2.5 minus 1.2. So it increased by 1.3 there, because that's a difference. It increased by 1.3, but that's a difference between the two. But what is written at the bottom? Always a starting point. Whether it's a decrease or an increase, what's at the bottom is a starting point. So there's a starting point. So it's going to be 1.2. So if you do this calculation, what you're going to write at the top, is it not 1.3? You subtract those two. The increase is 1.3. What's the starting point? You're starting off from day 2, moving towards day 3. You're starting off with 1.2. So it's 1.3 divided by 1.2 multiplied by 100, and you get the percentage increase. In this case, is something like 108% or 104%. It's a increase that you have there. So now we understand how to do a percentage increase or decrease. Please go and practice each of these. I'm writing them in red for you to go and practice before the test. And again, the second test, you practice them again. And paper 1 September, you practice all these again. Make sure you know them. Don't just say, I'm fine with it. Do not lie to yourself. Prove to yourself that you're fine with each of these type of calculations before each of the next 6 assessments. And by the time you get to the final papers, paper 1 and paper 2, you practice again and you do well, because you see how many marks are made up from the skills here. So now another question they sometimes ask is, let's look at this one. If they say compare day 1 to day 2, how many times is day 2 bigger than day 1? Now then you take the one that you're talking about that's bigger, you put it on top, divide by the other one. So the moment you get to how many times is something bigger than the other one, you must make a division sum. Divide. So if something is bigger than the other one, you put the big one on top, the small one at the bottom, you divide. And in this case, if you divide 1.2 by 0.5, you get something like 2.4. This is how many times this is bigger. You do a division question when they ask about bigger. So let's just run through these again. Average means you add up and you divide by the participants. You can practice all these again. Difference means minus. Percentage is an expression out of 100. Percentage increase, remember the starting point is always at the bottom. Multiply by 100. How many times bigger? You divide. You can do this, but you can't just listen to what I'm saying now and then go and write. You must go and practice these things. Let's look at one example. Here was a whole extract in the year 2016. We're still busy with 2016 paper. You see how many skills are asked every year in paper 1 and paper 2. Now, this was all about petrol in comparison to another kind of fuel called gasohol. Now, gasohol is what? It's a mixture of 10% alcohol and 90% petrol. But I see something interesting here. When I read this passage, I notice that the petrol releases so many megajoules of energy per liter. That's what petrol does. Now, gasol, they describe here as well, also releases a lot of energy. But I notice here, when I read here, that gasol releases less energy for the same liter. Look there, 34 megajoules for petrol, per liter petrol, and not 34, but 23 for this gasol. So this produces energy, but less than that one for every liter. So already I'm seeing trends. Always look out for the trends. So let's see what questions were asked here. So you read the passage and then they ask you, they ask there. But now let's look at the scientific skills, and you must always show all your working. You can't just write the answer, show all your working all the time, that you can give the marker a chance to give you marks. Calculate the difference in energy released by petrol in comparison to gasol. Show your working for 2 marks. Now that's easy, because we saw here petrol releases so much and gasol so much, and the word difference occurs. What did I say difference means? It's simply subtract, minus 34.8 megajoules minus 23.5 megajoules. You get the answer there. When you can even use your calculator. Remember to take always a calculator to the exam room, because you're not allowed to borrow. Take all the necessary equipment. You're not allowed to borrow anything in the exam room. So you subtract. Difference means subtracting. So there more theory questions are asked. You see how they combine the theory with the skills. So I wanted to highlight here the difference. Now, look here, some knowledge question on human impact on the environment. Thermal pollution, of course, has to do with temperature of the environment, of the water. Describe how the thermal pollution can impact on the quality of water. You can go check out that theory part. This is something interesting about thermal pollution. It's all has to do with how hot the water is. Sometimes factories pour hot water into the river. So now that was 2016. Let's look at 2017, once again, a graph, and let's see what story is this graph telling us. Let's read. The graph below indicates the amount of water in dams in each province shown as a percentage of their maximum in these dams. The information shows the amount of water in this year, 2016, in dark, and then by the end of February in 2017, shown there with a blank little bar there. So what does this tell me? So I've got different provinces here of our country, and I've got here how full the dams were. So what story does, before we look at the questions, let's see if we can see trends here. So I look at Eastern Cape and I see the water from this year went quite a lot down. The dams got empty from 2016 to 2017. This is what this graph is talking to me. Remember, we said when you see a graph, you say to the graph, talk to me, give me information. Free State, the dams got fuller towards 2017. It looks like there was rain in the Free State this time in February 2017. The water went up from 2016. The same with Gauteng, water went up. KwaZulu-Natal was a bit drier there. Limpopo up. Look at Northern Cape. It looks like Northern Cape had a lot of rain in February of 2017, because look there, it went up a lot. So we see the trends here. Let's see what simple questions are they asking. This was in the year November 2017. They asked this question. This was what the learners wrote. So you see how reasonable the questions are. Which province had the most water in their dams in February of 2017? Let's go and look in the graph. What is the highest? I see 95 is the highest. Which province? Northern Cape. You write it down. Mark scored. Which province had the greatest decrease in amount of water? And that is what science is all about, spotting trends. Looking at increases, decreases, but also the greatest increase or decrease. In this case, the greatest decrease of water from 2016 to 2017. Let's go look at the graph. I don't know, let's go look at the graph. I see Eastern Cape had a lot of decrease from there. It looks like that is a dry spell there. 72 to 58. Eastern Cape definitely here. There's a decrease there because we're looking for the greatest decrease. Free State no had increase there. There's a decrease, 52 to 47, not as big as Eastern Cape. Increase there, increase, great increase. We're looking for decrease, increase. There's a decrease, but also not that great in Western Cape. So which province had the greatest decrease? We can see clearly from 72 to 58, it's a big decrease, bigger decrease than there. That's Eastern Cape. So which province had the greatest decrease? The graph tells me. I'm allowing the graph to talk to me, and I'm scoring another mark. Now, the amount of water in the dams of Northwest increased by 33% from 2016 to February 2017. Calculate the percentage what? Now we come to a calculation like I said earlier. Calculate the percentage increase. So let's look at here. If you, we're looking at Northwest Province. Let's go to Northwest Province. So what was the increase? Now we said when you calculate a percentage increase, you must always do what did I help you with earlier to understand? Remember, we're looking at Northwest. We said you must always go and calculate the increase. Now the increase is obviously the difference. Because we're working with percentage, we always say we multiply by 100 because this is now percentage we're working with. And you're going to divide it by what? When you calculate percentage increase, you must divide by, what did I say in my previous statement? You must go and divide by the bottom, always the what? Always the starting point. So now let's go look. Northwest, the question was, how did it increase? What percentage increase is there in Northwest Province? So what will I write at the bottom? Will I not write 44.7? Because that's the starting point. At the top, what will I be writing at the top? I must write the increase. Now, what is the increase in Northwest? Because we're dealing with Northwest. So I must go find it. Increase from 44.7 to 78.1. If you take out your calculator, you will see if you subtract those two, because that's the increase in real numbers, it will be what? It will be 33.4. If you calculate that. But because it's a percentage, we must always multiply by 100. Now quickly do that in your calculator. The dams in Northwest, because that's the question, by what percentage did they increase from 2016 to 2017 there? The difference, multiply by 100, divide by the starting point always. Doesn't matter if you calculate percentage increase or decrease, you always write the starting point at the bottom. And if you do that calculation, you get to something like 74.72% increase. You show your calculations completely and you write the answer and you write the units at the back. You give your answer 74.72% increase. Make it clear for the marker. Whatever you know, do not keep it for yourself. Put ink to paper that you give the marker something to work with, because that's what you want. You want the marks that you deserve. So there we've done that for 3 marks. Very, very interesting. What did we calculate? The amount of water in the dams of Northwest was, it increased by that from there to there, but now calculate the percentage increase over 2016. So that brings you to 75%. So which 2 provinces had the lowest amount of water in their dams in February 2017? Let's go. February 2017 looks like this. Where was the lowest? I see Western Cape is low. Yes, so Western Cape is one of them. What else is low for there? I see KZN is low. Those 2 are the lowest of the unshaded bars there. They are the lowest. So there's your answer, Western Cape and KZN. So no problem with that. So here's more theory questions. Another skill you need, I've indicated in red here, and remember I'm putting this document for you under resources that you can go and practice again, is you need to be able to make simple drawings like you would have in meiosis, for instance, when they ask you to do drawings. I saw this question in 2017, paper 1. I think we're dealing with 2017, November. Look here, very simple. But you need to take your pencil with, because sketches will be done in pencils and labels are done in pen. Whenever you draw a diagram, always provide it with a heading, please. The diagram below represents a seed starting to grow, like you did in primary school when you put it on cotton wool and the seed starts to grow. Assume that the little root, the radicle, and the plumule were exposed to uniform light from all directions, so there they grow. Now they ask, draw a label diagram to show the position of the little root and the stem a week later. So all the examiner wanted for 4 marks is for you to go and make a sketch, and you know what happens to a little stem. It's going to grow upwards and the little root is going to grow downwards. This all has to do with tropisms. So what is a tropism? It's a growth movement that is caused by a stimulus. The stimulus for the root will be gravity, geotropism, and the stimulus for the stem will be phototropism, the light, so growing upwards. Now draw this. Now look how we gave marks that here as markers. The learner had to draw, obviously, you're going to draw the root is growing down and the stem is growing up, but you must always give a heading. You can write the heading at the top or here at the bottom, but we call it the caption. So here's the instruction checklist for the marker. You had to check, did the learner write a heading? Caption, you give 1 mark. Proper heading to describe what is this. Then the drawing had to be correct. We gave 2 marks. And then for the labels that you make in pen, we gave another mark for 1 correct label, and the learner got 4 marks there. So you can see that you can score marks at the end of the year. There's no problem for you. Something that's normally tested is a very important aspect of any scientific investigation. I must ask myself as a researcher, a scientist, is my investigation reliable and is it valid? Now, reliability, the R stands for the ability to repeat it many times. So if they ask you, how can you increase the reliability? Is repeat and take the average. Or you can do it by a greater number of participants. So this is how you increase reliability, is by having reliability means repeat. You take the average and also have a greater number of participants, then you're increasing your reliability. Do not mix up reliability and validity. Those are different things. Reliability has to do with greater number of participants. So like for instance, if I look here, I'll come to validity now. What does it mean to make your investigation valid? They can put a stamp on to say this investigation is true, it's okay, we can trust it. That is validity. Reliability is using a greater number or repeating it. It's R. Please always write that. You will always score marks. R, repeat reliability. Now look at this one. An investigation was conducted to determine the effect of different amounts of thyroxine, that hormone, on metabolic rate. The procedure was as follows. They used here 9 adult male rats. Now, in my mind, it's not enough. If you want to do a scientific study and you only have 9 participants, how can you make your investigation more reliable? If you could use, let's say, 200 rats here, not just 9, then your investigation becomes more reliable when you increase your numbers. Repeat the investigation and have greater numbers. Validity has to do with keeping everything the same. Validity has to do with keep everything the same. You only change the thing that you are testing. Validity has to do with you keep everything the same. You only, like here, they only used males. They didn't use sometimes males and females. It makes it valid here, the fact that they only used males in this case. So there's a difference between the validity of an experiment and the reliability of the experiment. Reliability has to do with greater numbers are better, and validity has to do with that you follow proper procedure, that you keep everything the same. like in this case, when you test these rats, you want to keep them in the same size cages, that some don't have more space to run, because you don't want, when you test thyroxine on metabolic rate, you're just testing the thyroxine. You're not testing temperature. You must keep the temperature the same. Just keep the cage the same. You must keep the kind of mice you're using the same. So that makes your investigation valid. When you keep everything the same, you're just changing the thing that you're testing. The thing that we're testing, we call the independent variable. So let's look at this investigation. They were testing the effect of thyroxine on metabolic rate. So that means, what is the effect of thyroxine on your metabolic rate? So immediately before we go in, we identify here for ourselves, thyroxine will be the what variable? Please, you can say. Thyroxine will be the what variable? Independent variable is the thyroxine, because that is the cause. And the metabolic rate will be the results, isn't it? The effect. So that will be, the results is always called the dependent variable, because the results depend on the other one. That's a dependent variable. So we want to investigate, if these mice here eat a certain diet with thyroxine in, how will it influence their metabolic rate? The metabolic rate has to do with what? Metabolic rate has to do with energy production, the production of energy. So some people, even with animals as well, when you eat food, the food you get, which is converted to glucose, the glucose is then used to form fat, because they're not producing energy. They're not active, they're not working, they're not moving, they've got a low metabolic rate, they're not producing energy, so then the glucose goes into fat. Other people, and you've seen people like that, they eat a lot, but they stay skinny, because all the food they consume is converted to energy. They have a lot of energy, sometimes too much, and they get naughty. You see it with the grade 8s and 9s at school. So if I'm going to inject somebody with a lot of thyroxine, in this case it was used on animals, a lot of thyroxine, you're going to produce more energy and you're not going to put on weight. So now that we keep that in mind, let's just read here what was done. Investigation was conducted, and they did this on mice. They gave different amounts of thyroxine, that hormone, and they checked out how did it influence the metabolic rate. Now, they did it as follows. 9 healthy adult male rats were used. They were grouped in 3 groups of A, B, and C. All 3 groups were kept under the very same conditions. Each group received the same amount of water. We did not want the water to play a role. Each group was given now a different diet. They took the mass in the beginning, and then the mass 3 weeks later again. And they also checked the energy consumption, the oxygen consumption, because the more oxygen used will indicate for me and you how energy was produced. Because if you're going to use more oxygen, you're going to produce more energy, and thyroxine is going to stimulate this whole process. So what's the difference between diet X, Y, and Z? X was just a normal diet. There's X. And let's just, before we look at Y and Z, see what happened to these mice here. They were given this normal diet, and they picked up a little bit of weight. We see that. Y, this diet is different. This diet still contains the same food, but something added. In this diet, what was added here for the mice? Look here. For this group Y, thyroxine was added for them. So it looks like they're not going to put on weight. They're rather going to change their food into energy. This group Y. That's already what I can see before I look at the stats. What's the difference between Y and Z? Z is food containing all the nutrients, just like all 3 of them have the nutrients. But here's a chemical that works against thyroxine. So thyroxine is going to increase your energy levels, but Z contains something that rather is going to cause you not to produce energy. The food you take in must rather be changed to mass. Let's see if the stats here tell me that. Remember what X was? X had nothing in. It was just the normal food. But now look at this one here. These mice lost weight. Look, they started off with this, and 3 weeks later, look here, now they weigh less. I think this was the group where they got the thyroxine, because they rather used even their body fat they had into energy. And these mice here, they picked up a lot of weight. They got quite heavy after 3 weeks. So I can see it must be this diet Z that was given here to the group C, because they did not have thyroxine, so they increased in weight. Now let's look at the questions that were asked here. Let me just clear my drawings here and then we move on. Name the groups A, B, or C in which the average mass of the rats increased. Where did they increase? A increased and C increased. Scoring 2 marks, I'm getting the answer from here. So the answer is, let me just look at the stats here. For the investigation, always asked, what is the independent variable and what is the dependent variable? And how was the dependent variable measured? So what influenced what? Did we not say the answer was given already? Go read here. The independent variable, the cause was the thyroxine, and the dependent variable is the metabolic rate. How did we measure the metabolic rate? We measured it in terms of body mass increase of average mass, and we also measured it on the oxygen consumption. So that answers this question for us. So no problem in answering that. Now arrange the diets X, Y, and Z in order of increasing amounts of thyroxine that would be found in the rats after they were given these diets. So we said, okay, there's X. Remember, that was a normal diet. And we said B is obviously the one with where the thyroxine is. So which one was that? If we go back, which one was the one where the nutrients were with the thyroxine? It was Y. So B, I can put in here Y. So that one was Y. And the one where the thyroxine was not in fact, there was a chemical working against thyroxine. That one was diet Z. So I can put in, now I know, sorry, Z. Now I know X, Y, and Z were given to those 3 groups according to that. So keeping that in mind, the question now says, it asks what here? Arrange the diets X, Y, and Z in order of increasing amounts of thyroxine. So you'll remember that Z was the one with the lowest thyroxine. In fact, it contained chemicals that worked against thyroxine. Then there was X with a normal diet, but then there was Y, which contains the thyroxine. So when learners wrote it like that, that year we gave 2 marks if they wrote the correct order like that. Now, which group, B or C, was given diet Y? And what was diet Y again when we go back to if we go back to the information, diet Y contained the thyroxine. So we said diet Y was here at B because they lost weight. And they also use a lot of oxygen to convert their food rather to energy. So you see these mice became skinny. It all has to do with the effects of thyroxine. Now state 3 ways in which the validity. Now do you see this word? It's not reliability. Reliability has to do with numbers. But here they want to know what will make my investigation more valid. So state 3 ways in which the validity of the investigation could be increased. One could be to be sure that you use the same species, the same kind of mice. So if a learner writes here, more mice could have been used, it's not right because that's reliability. So that you use the same kind of mice, same age, because age could also play a role. And then you keep them in the same size cage, because if you keep some in bigger cages, they have more space to run around. So you could even increase the validity by, you can just say, what must you keep the same? Validity has to do with keeping everything the same. So I think you've learned a lot so far. Let's look at some other. November 2018, there was a multiple choice question. It all has to do with our ability to interpret graphs. The graphs below represent the results of an investigation to determine if there's a possible relationship between temperature of the water and dissolved oxygen in the water and the size of the fish. So I'm really forming the picture. This is all about, are the fish growing bigger where the water is perhaps colder? Is it so that colder water or hotter water has less oxygen, then the fish can grow bigger? Let's see what the graph tells us. So my advice to you is always go to the x-axis. Here's the x-axis. What are we seeing here? As the water temperature increases, what happens to the oxygen in the water? When it's low, the temperature is low here and it's getting hotter and hotter and hotter. When the water is cold, there's a lot of oxygen there. But as the water is getting hotter and hotter, look at here, now there's little oxygen. If you read on the graph here, sorry, I must just go straight there. There is little oxygen in comparison to there at the top as the water got hotter. So now I can come to the conclusion, the hotter the water, the less the oxygen is. This is what this graph is showing. You can see it there. What does this graph show me? If there's more oxygen in the water, as the oxygen increases in the water, the fish grow bigger. They grow bigger in size over time as there's more oxygen in the water. Now, let's go look at the options of the multiple choice. So the graph has told us a story. Let's look at the options here. Which one of the following is a possible conclusion I can make based on what I see here? There's no relationship between water temperature and fish size. That's not true. We can see there is, because a no relationship would be a straight line. This is a straight line. So there is a relationship. As the temperature of the water increases, the amount of dissolved oxygen also get more. That's not what we saw here. We saw, so B is not true. As the water temperature gets hotter, the oxygen gets less. Here they say, as the temperature increases, the dissolved oxygen also increases. No, it's not true. Let's go to C. The average size of the fish will decrease. That means the fish will get smaller. They will not really grow as big as the temperature increases. Yes, that's absolutely true, because we saw here, lower water temperature causes more oxygen. And if there's more oxygen, then the fish grow bigger. So here it says the average size of the fish will decrease as the water gets hotter. That's a fact. But now let's look at D. Isn't D perhaps also correct? D says the amount of dissolved oxygen in the water will not influence the fish size. No, we see it does influence it. So the only option that's correct is number C. That is quite obvious. So I'm not going to discuss these that I've included here for you. You can check them out on the section on the resources. What I've included, this comes from 2018 and 2019 papers. I think we've discussed all the skills. The last skill that we need to discuss is your ability to draw graphs. Can you draw a pie chart? Every year when pie charts are asked, like this year, I think this was 2018, or was it 2019? 2019, paper one had a pie chart, and then learners did not take with them the correct equipment, protractor and compass, and then they could not draw it, they lost 6 marks. When you get a pie chart, show all your calculations, show everything, go and find out how to draw a pie chart. Practice it, that you know how to draw it. If they're asked to draw a line graph, you draw nothing else but a line graph. Can you draw a histogram? What's the difference between histogram and bar graph? Bar graphs have spaces between the bars. Histograms, there's no spaces. So you need to be able to draw this. How do we as markers, I've got here paper 2 example of November 2016. How do we always mark? Normally it counts, these graphs count 6 marks, and you will get graphs to interpret. You'll also get graphs to draw. Know how to draw all these graphs. We give a mark for the heading. That's 1 mark. And the heading must include both cause and effect. Something like line graph indicating the effect of brightness of light on the size of the pupil. The independent variable and dependent variable must both be in the heading. Make it clear. Don't just write something like brightness versus pupil size. No, you lose a mark there. Move away from that thing versus write a proper sentence as your heading of your graph. Then you score 1 mark for including both cause and effect. Then the type of graph. If we ask you to draw bar graphs, you get a mark for T for type. That's how the markers work. Then if you plotted the points correctly, you indicated your key and so on, you get another 2 marks there. And then for spacing your correct spaces here on the x-axis and you label it properly, you get a mark for the x-axis. And then the y, you must have your scale correct. If you go with 0, 10, 20, you jump with 10 every time. Don't just suddenly in between put 55 there or something. Keep it the same spaces, same gaps you make in between so that you can get your scale correct. And then you indicate, what is this? Put the units in brackets. Is it centimeters? Is it kg? In this case, it's percentages. Put the units there. Remember, what you put on the y-axis are always your results. And this is the cause. And then you plot the graphs correctly and you get 6 out of 6. I want all of you to get 6 out of 6 for this. You can do it. And I'm sure you are much more positive now. Please watch this lesson again if necessary, and practice. Go through these questions, go through old papers, and see how we always ask the skills. The skills are always asked. They will be asked in the 2 tests, the 2 papers in September, and the 2 papers again in November. I hope you do well. Best wishes.